Hello everyone, welcome to another exciting math problem in the field of number theory. Today's challenge involves integers and equation. Here is the problem. Suppose we have two integers x and y and they satisfy the equation x squared plus 2 equals y times x plus 3. Can you find all possible values of x, y? Before we jump into the solution, I encourage you to take out your pen and paper, ponder the problem, and try to solve it on your own. When you're ready, please share your answer in the comments. And let's explore the solution together. Ready? Let's dive in. We are going to tackle this problem using two different methods. In our first attempt, we'll write the given expression as a quadratic equation in x. Then we'll consider the discriminant, which is y squared minus 4 times 1 times 2 minus 3y. We'll complete the square and obtain y plus 6 squared minus 44. Since x and y are integers, the discriminant must be a perfect square, which we'll denote as u squared for some integer u. Now, we have u squared equals y plus 6 squared minus 44. And the difference of these two squares is 44. Using the formula a squared minus b squared equals a plus b a minus b, we can factorize these as y plus 6 plus u times y plus 6 minus u equals 1 times 44 or 2 times 22 or 4 times 11. Since 2u is the difference between y plus 6 plus u and y plus 6 minus u, and is clearly even, so both y plus 6 plus u and y plus 6 minus u have the same parity, meaning they are either both odd or both even. So, we consider the possibility for these values. By solving this equation, we find the pair uy as negative tan 6, tan negative 18, tan 6, and negative 10, negative 18. Now, for the corresponding value of x, if y equals 6, using the given quadratic equation, x squared minus 6x minus 16 equals 0, we find x equals 8 or x equals negative 2. If y equals negative 18, using the given quadratic equation x squared plus 18x plus 56 equals 0, we find x equals negative 4 or x equals negative 14. So, the possible value of xy are 8, 6, negative 2, 6, negative 4, negative 18, and negative 14, negative 18. That wraps up method 1, which starts by creating a quadratic equation in x. Now, let's move on our second method, which begins by solving for y. We have y equals x squared plus 2 over x plus 3. We'll write x squared plus 2 as x squared minus 9 plus 11. Notice that x squared minus 9 can be factored as x plus 3 times x minus 3. So our expression can be simplified as x minus 3 plus 11 over x plus 3. Since y is an integer, we know that x plus 3 is a factor of 11. This means that x plus 3 can be equal to plus minus 1 or plus minus 11. Solving this equation, we find x equal negative 4, negative 2, negative 14, or 8. Hence, the value of xy are the same as in method 1. That is negative 4, negative 18, negative 2, 6, negative 14, negative 18, and 8, 6. These conclude method 2. In this lesson, we successfully tackled the problem using two different methods. My personal preference is the second method, but knowing multiple approaches can provide different perspective and insight. What is your preference? Thank you for joining me today, and I hope you enjoyed this lesson. Until next time, take care and bye-bye.